Welcome back to this fifth lesson. We're gonna kick off using some methods from the Revit API just to understand how we can convert and read properly the information about length of the objects. And at the same time, I'll try to introduce you to how we can convert internal units into real units, into project units. So first of all, let me kick off just using this wall as a reference. So if we can see that if we go under the project units, this specific wall, this specific project is managed into meters. And so if I go and select the wall, the length of the wall is 2.1 meters. And of course, if I switch into another project units like millimeters, we all know that Revit is gonna do the conversion for us. So the wall will be 2,100 millimeters. So this is what we call the project units. But eventually, Revit is not going to work using these specific units. Those units are called display units because Revit is always working internally using an imperial system. So I'll try to demonstrate this using the Revit Snoop, just going under the add-in and opening the Revit lookup and check under the Snoop current selection. So if I check this wall parameters, we can quickly go into the length and see that the length at the moment display unit is DUT, which stands for display unit millimeters, just because the project is set up in millimeters. But if we switch back into meters, and we go back and select again under current selection, under parameters. So we can see that the length now is the display unit is meters. But if we scroll down a little bit and we check under the methods, we can see that first of all, the storage type of this specific parameter is double. That means is a number. Whereas if you go on the, for example, the type name, the storage type is a string, of course. If we go under comments, the storage type is again a string. In this specific case, there's no comment here. And if we go under, for example, top constraint, which is a level for a wall, we can see that the storage type is element ID. So depending on the type of parameter, we will have different storage types, and that would be the way we can extract the value from the parameter. So if we scroll back again into the length, we can see that it's a double, and the value is 6.88, which is not exactly what we are expecting, because we are expecting something like 2.1 meters. So that demonstrates that internally Revit is using a different unit system. And if we go and query this value from the parameter, we will get this 6.88. So let me try to demonstrate it using Dynamo. Let's go back into Dynamo. So this specific lesson, here you can find the template. I already explained what this template is. It's basically trying to import all the libraries that we need to be able to manage, for example, the operating system, or to manage geometries, the Revit API UI, the Revit API, some of the Revit nodes, which will be useful to convert object between Dynamo and Revit. We'll get to that in the second part of the lesson. And the Revit services, which will allow us to access the document information the active document information and the transaction manager, which again we'll have a look into the next part of the lesson to be able to create object in a project. So let's park this template for a bit and let's focus on this script. So I've already created the script, but I just want to go step by step with you and try to explain what I've done with this script. So the first part is pretty straightforward. Is a collector. Again, I've already explained multiple times the collector, but if we go back to the Revit API documentation and we search for filtered element collector, we can see that the filter element collector has a different constructor. One of the constructor is providing a document, and then we have some methods where we can, for example, identify a specific category, and the category is a built-in category, which means is an enumeration type. And this is the list of enumeration types that we have in the Revit APIs. So going back to the script, we can see that I'm creating a new filter element collector. And by the way, in the API documentation, if we go back to the filter element collector, there are some examples around the of category. And you can see if you click on the examples, you will see that more or less the code I'm using is very similar to this one, except this one is a C#. So we don't have the new syntax, but we don't have to declare the type of the object. So it's very similar, except for the new. And so we're creating a new collector, a new filter element collector on the document, which is the active document. And the category will be the built-in category OST walls. Again, if I go back to the object, I'm always going back and forth using the Revit lookup because it's the way I've learned, and I think it's the best way to query the object within the project. So if we go back here, we can see that the wall, the category of the wall, it's the name of the category is built-in category OST walls, which is exactly what I'm using in the script, really. So let's go back over here and let me check this one. Edit. And this is of category, built-in category, OST walls. And what I'm trying to do with this filter is to remove whatever is an element type. So we don't really want to collect the element types. We want to collect the instances of the objects. So we want to exclude from the collector whatever is an element type. And we want to get the element IDs of the objects. So if I let me just create another wall. So what this script does is exactly what the out-of-the-box node using the categories and all elements. All elements. Come on. All elements, not of type, but of category. Which is this one. So we select the wall. This is just a better way to see the name, but is definitely going to do the same things. So we can see that this one is are the two walls that we have in the project. And if I go right here and instead of I can comment this part for now, and I can just output this collector. right here. Yeah, probably I need to remove this out from here. The output of this object will be exactly the same. So we just getting the element IDs. So we're not getting the object itself, but this can be converted into to elements, and that will provide you exactly the same output. I'm trying to get the element IDs because of the way we need then to retrieve these objects in the document. So if I then jump straight into this for loop, this for loop will just go through the elements within the collector and get the element within the document. And the way the get element works, if I go back into the API, so the get element will just ask for an ID, and will provide, of course, the selection of the element. So it's exactly what we're trying to do here. We have a list of element IDs, and we go to iterate through the IDs to get the element. I can, for example, create a new array and just, for example, add these elements to the array, and then try to output the elements. And again, this should give me exactly the same result. Whoa, it's just locked. Interesting. Okay, that was a bit of bad luck. I had to restart Revit. Very strange. It went just froze. But yeah, basically, what I was trying to do was to create an empty array and then collect the element from the collector, and add these elements to the array, and then just try to output the array at the end. So the result is again the same. So the next step would be to go and try to get the parameter from this object. So now that we have the wall, the single wall, we can go and query some of the parameters. And the way you do it is to use basically the get parameter on the element. So if we go back again into the documentation and we search for get parameter, you can't really find it because the real method you can find is get parameter in this way, and then we can go to here and search for, it's not this one, get parameter. Get parameter, maybe this one. Yeah, I just want to find the right method within the documentation. So let me go just back to the Revit DB and search for get parameter. Just get parameter, all of them, and then we go on the sub element, the family manager. It should be this one. This one will give you the name. Yeah. So if you search for get parameters and under the element, the DB element namespace, and you go down into the documentation, you can see that one of the ways is to use the get parameters and then provide the string name. which might contain a typo. So it's not the safest way to do it. It might be the right way just for the custom parameters. But if you wanna reach out to a built-in parameter, there are the second approach is to use the get parameter and then providing the built-in parameter as a string, as an option. So that's exactly what I've done here. So I've provided the get parameter, and then I've provided the built-in parameter, which again is an enumeration type. So going back again to the documentation, we can search for built-in parameter. And this is exactly the list of all the built-in parameters, which is very extensive. So usually the way I can find what's the proper name of the built-in parameter is again going into the Revit lookup, snoop the current selection, go into the parameters, check the parameter that I need, and then there's an internal definition. Internal definition will give you exactly the name of the built-in parameter, which is curve element length. So it's built-in parameter dot curve element length, all capital letters here. And this one will give you again also the storage type, which is double, which is again important here. So if you go back to the script, you open this one, we can see that exactly what I'm doing is to get the built-in parameter dot curve element length, and I'm getting this value as a double. So what let me just remove this one. We probably don't need it. So once I'm doing this one, I'm kind of creating a new array where I want to store these values, and I'm calling this value this array length imperial, which is here. So I'm collecting the value here, and I'm just adding the value right here in the proper array, and then I'm just exposing this value to the output. So let me just save this one, then run it. Well, if we check these numbers, are not exactly the numbers that we are expecting, because one is 1.1 meters, which I assume is the second one, and this one is 2 meters, which I assume is basically the first number. But if I go again and check these values over here, and I go on the parameters length, so this number is the number exactly that is matching the output within the Python script. So that's why I'm getting the real number, which is the internal number of the length. So how can we get the real number then? Let's jump back again into the documentation, and let's search for unit utils class. So the unit utils class contains some methods. The two of them we're really looking are convert from internal units and convert to internal units. So the convert from internal units is the one we want to use to convert the number from imperial or from whatever Revit is using as a core unit system into the unit system that we want to see. And basically what this method is accepting is a value, which is the value of the parameter, of course, and a display unit type, which is exactly what I was trying to mention at the beginning of the lesson. So if you click on the display unit type, is an enumeration type, and those are all the types of units that Revit is able to handle. that are not just related to the length, but they might be related to areas, volumes, or forces, or voltage, or whatever is the unit that Revit can handle in terms of all the disciplines. So we are really interested into a couple of them at the moment, which might be the meters, the centimeters, and the millimeters, and how we can use these functions then. So if I check back into the code, I've already placed the code over here. But before doing that, I'm just going to do a little modification. So we said we want to read a value, which is the length, and then we want to convert that into a display unit type. And we might be just, I don't know, DUT_meters. So if I run this and I add this value to another array, which then is named length metric, and then I expose this length metric to the output. Again, let me say save and run. We can see that now we have a proper value here. So the 6.56 is converted into 2, and the 3.60 is converted into 1.1. And now it's definitely correct, because the project unit system is meters, and so we're getting the right number. But what if we convert this one into millimeters then? And then we rerun the script. So as you can imagine now, the numbers will still be the same, even though the unit system is changing to millimeters. And that's because we are forcing the conversion into a specific display unit type. This might be converted into millimeters. Then we can run this, and then we can get the millimeters or centimeters or whatever. But this is not really efficient, because every time we want to change the project unit, then we need to go and tweak the Python script to be able to get the right project unit system, unless we want to always force the unit to be in a specific unit system. So there's another method which we can use to get the value of the display unit active in the project at the moment, and that is using the format option. And the format option will get as an input which type of measurement we want to get. So for example, the length. So let's go back again to the documentation, get format options. So the format option, as I said, it's probably not this one. It might be different. It's under the units. So the format option is expecting a unit type, and the unit type is again an enumeration, and those are all the types of unit systems that we can handle with Revit. As I mentioned, we might have volumes, area, angles, numbers. We might have power or velocity or any other system that you can tweak in the project unit. At the moment, we're just interested into the length. And so the way we can access this is to, first of all, access the units within the document using this get units. And then we can access the format options for the length. And then we want to access the display unit value for this element. It seems to be a bit tricky, but if you memorize this line of code, you can really do whatever you want. You just need to change the the type of measurement you want to get. And so instead of going here and hard code the value, we can just type this variable, which is format option. You might change the name, of course, and this will then provide you with the right format option. So if I go here and change it into centimeters, for example, sometimes you have to just add and remove an element, an input to be able to rerun this Python script if there are no inputs to the Python script. And so you can see that now is correct. And if I move back into meters and rerun this one, this value will be correct. So that's the way we can get the proper values. And this might be for anything. I just going forward with the script, I just try to demonstrate that if you go back again using the convert to internal units, this one will get again a value, which is now the value in meters or millimeters or any project unit we're using. And again, it takes the format options, which in this case is the unit that from where we are coming from, and so will be the same, of course. Again, another array for this new one, and exposing this new array at the end, and so we'll get back and forth with the same numbers. So this number will be again the proper number. It seems that this is quite tricky. But it's not. Once you understand that you have to handle these numbers properly, otherwise you don't get the proper, for example, measurements. It is important to mention that those conversions are also needed if you want to plot a specific object in a specific location, because the X, Y, and Z are also measured as a length from the project base point, and so those are managed as well as elements using the internal units. We might just get a quick overview. If I get this element here, let me place it in the right. Let me just move this one to 0. And this one to 0. So I'm kind of expecting that the X value might be 0.6. But if I check this element and I go into the current selection and I'm trying to get the location of the object and the curve which is driving this object, I can quickly see that let me see, the origin is 1.96, which is not 0.6. And that means that this value is also in internal units, like the length. And so if I want to know the X and Y of this object, or if I want to plot an object with specific X and Y, I need to convert into or from the internal units. So just bear in mind this one when you try to use Revit, because you might end up to get the wrong location of object, and that's due to the internal units. So that was kind of way of explaining how we can get this right. The second part of the lesson now is more focused on creating object from scratch, so placing object within the project environment. And to do that, we need to do just basic things, but it is important to get it right from the beginning. So first of all, again, I have this working right here. What I'm trying to achieve is to have a line, let's say detail line, for example, and I want to just draw elements following this line. So if I go back to Dynamo, my first selection is the line itself, and if I run this one, I can see that there's a line here. Oh, good, very easy. Then I can use, for example, something like, let me try to create an object. Very simple, just a quick family. Maybe a column. Just let's use a column. So let's use this this squared column here. Very easy. And let's go back to here. Let me select the column. This will be the level where I want to place the object, and I'll try to explain this one in a few minutes. And I'm just using this refresh to avoid, to add and remove the inputs to be able to rerun the process from scratch. And this will be the number of objects, or the distance between the object I want to get, and that is going to be the curve. So before running the script itself, I just want to inspect the code. So the beginning of the code is just the boilerplate coming from the template, again, accessing the Revit API, accessing the UI, which we don't really need at this point, but it's a boilerplate, so you can copy and paste whenever you need it. What we really need here is, first of all, the document, which is fine. And what we need is the transaction manager. So whenever you want to create something within Revit, you have to do it inside the transaction. And that's because Revit is basically a relational database. So it wants to know exactly when you're trying to access the database to write something. So you don't have two different transactions happening at the same time on the same object. So whenever you try to do a modification, you will do it through the transaction. So when the transaction is closed and when the transaction is fully executed and there's no errors, then Revit will go and write down these things inside the database. Otherwise, you can roll back. You can trigger some message box to say that something went wrong, and so on. So whatever is your code is going to happen within a transaction, and that's where the transaction started. Of course, the transaction needs the document as an information. And here is where the transaction is done. And that means if there are no issues within these two lines of code, we can create physically the object within Revit. So there's another things we have to mention when we use Dynamo with the Revit objects. And is that Dynamo is basically a plugin on top of Revit, so we can access the Revit API. But to be able to access the API, the Revit API and the objects, we need to encapsulate these objects. And so what basically Dynamo does is to use specific types and to be able to access objects that are straight coming from Revit, we need to do what is called an unwrapping of this object. So basically, the family type which is coming from Revit is wrapped into an object and then sent to Dynamo. And when it reaches Dynamo, we need to unwrap these objects to be able to access the information. So anything that is coming from Revit as an input needs to be unwrapped before being used by Dynamo. And so you can see basically that we don't have to unwrap the curve, because the curve is already unwrapped by this out-of-the-box node. This unwrap element is happening really inside this node here. And so the element object coming from Dynamo is encapsulated and then unwrapped inside this node into a Dynamo curve, which then can be fed into the Dynamo script. But the family types itself is coming straight from Revit. And so before using that, we have to unwrap it. Same the distance. The distance is just a number, so we don't have to do anything on that. The level, it's again something that is coming from Revit and is an input from Revit. And so before using that, we have to unwrap the object. And that's why we are unwrapping the level here. And that's just the Revit owned is a Boolean. It's a Dynamo. It's a Dynamo object, so we don't have to do anything. And same, this one is a Boolean, so we don't have to do anything on this. So the next step will be to just check if this refresh is true or false. If it is false, this doesn't get executed. Otherwise, if it is true, we can execute whatever is within this if statement. So very basic Python. The next two lines are pretty important because they can generate some error. So it's a bit tricky to explain it, but let me try to say it. So when we load the object within the document and the object has never been placed within the workspace, the object is physically loaded into the model, but is not activated in the project, and that will make the things a little bit easier in terms of performances, because we can load hundreds of families, but until we use the family once in the model, that family just stays there, not active. But at the moment we use that family for the first time, that object is activated, and then that element becomes an instance inside the project itself. So if we don't have any of these columns within the project, the object itself is not active. And so the first thing we have to do is to check if the family that we want to use is already activated or not. And if it is not, we have to activate it before using it. And so that's basically what I'm doing here. I'm checking if the symbol, which is the family type, is active. It's just a parameter of the family symbol, which you can always quickly check here. So it's basically a method of the element. There might be another. Yeah, is this one? Sorry, is active property of the family symbol. And so this will explain that the symbols that are not used in the document may be deactivated to conserve memory and regeneration time. So when the symbol is inactive, its geometry is empty and cannot be accessed. So in order to use it, we have to activate it. And that's what I'm basically doing here. And then I'm just wrapping everything into a try except, which will save me if there is any error executing this specific task. And I can also output this if there is any issue. So the next will be basic Python. What I'm trying to do is to go from the value of 0 in the length of the curve up to the length of the curve. and I'm just using some step distance, which is just adding this 8 value to each step that I'm taking along the curve. So it's nothing to do with the creation of the family. This one gets the point at the segment length. Again, very simple. What I'm really here, what is really different from a basic Python geometry within Dynamo, is this 2 x, y, and z, because what we create using this first part is a Dynamo point, but what we need to be able to plot and create the instance is a Revit point. And so this method here, which is a Dynamo method, is not really a Revit method, will convert a Dynamo point into a Revit point. And that's exactly what we need to be able to, it's basically doing the conversion between the X, Y, and Z of Dynamo into the internal X, Y, and Z of Revit. So we don't have to use the unit utils because these 2 X, Y, and Z is already doing the conversion for us. And so then I'm just using appending this value to the list of points, nothing special. And this time I'm trying, because I want to see the point within Dynamo, I'm not using the 2 X, Y, and Z because I just want to plot the Dynamo point. And here is where the magic happens. So this is probably the most important line of this code. So let me just try to explain it as best as possible. So we need to create a new family instance. And so you can go back here and check the new family instance. And this part of the creation document. So we have different constructors for the new family instance. We can use a curve if it is a curve-based component, or we can use an X, Y, and Z, a level, and the family symbol, which is exactly what we're trying to use. So we need an input as an X, Y, and Z, which is a point. We need a family symbol, which is a family type. We need a level. We already have the level. It's a datum. And we need to identify the structural type, which is an enumeration. So we can have different structural type. Might be non-structural most of the times, or if it is a structural element, might be a beam, a brace, a column, or a footing, or any other things. So we can just define it. We can definitely say that this is a structural column, or we can just say that it's not structural. It's not really important at the moment. So we have the point, which is this X, Y, and Z, which is a Revit point. We have the symbol. The symbol is coming as an input from here, is unwrapped, so it's a Revit object now, it's not a Dynamo object anymore. We have a level, which is again not a Dynamo object anymore, it's a Revit object because it has been unwrapped. And this one is an enumeration, so it's just structural type, not structural. And let me keep this one just for a few seconds, and I'll come back to this 2DS type. So once this one is created, I'm just appending this to an element. I'm trying to output this message here, but nothing special. And then I'm moving to the next step. So if everything is working, I can already output the elements and the points. Otherwise, I will output whatever is the error string that I'm getting from the execution. And then I can close the transaction. So let's save this one. Let's save this one. And let's run it. So boom. We can see the point here. And we can see the columns here. Let me just move into automatic. And I can move this one. So the more I move this one, the more object will come just because, I'm changing the step between the elements. I'm not rotating the elements. I'm not really interested now into getting the elements here rotating. I can stop the execution, moving into this one, or I can just rerun the execution. So it's very busy, basic exercise. I can tweak this one here. And I can move this line here. I can, for example, create another one right here, and then I can just swap the line into this one. So imagine that this workflow can be quite interesting if we start to use, for example, trees, and we want to place trees along a curve, or we want to place lighting fixtures. So it's very interesting. It can be very useful for different things. But as you can see, whenever I move the line, the object will be recreated, because that's what it does. Dynamo is basically owning the objects. And so if I go back to the script, this is basically what that 2ds type is doing. So 2ds type is a method that defines who is the owner of the object. And so because I'm using a false value here, that means that is not owned by Revit. So I tend to call this value is Revit owned, just because it's easy then to understand that if it is false, that means that Dynamo is the owner. If that is true, that means that Revit is the owner. And so for the people that are used to use Grasshopper, this is very similar to bake objects in Grasshopper. So let me just quickly move this one up to here, and then I wanted to swap this into true. And look what happened if I then move the line over here. So the object will be recreated, and every time I move now, those objects will be recreated, just because Revit is the owner and not Dynamo anymore. But if I want to keep the things dynamic, I can just swap this one into false again. And then if I move the line, those objects will follow the line. So it is very important to understand when we want to swap this between the two owners, which might be Dynamo, might be Revit. And this is basically done by this method when we start to create. It's kind of wrapping again the object and send it back to Revit using this one, whereas the unwrap is unwrapping the element from Revit to be used in Dynamo. So it's kind of wrap or unwrap. It's just called in a different way. But I like to think about that. This is exactly the vice versa of the unwrapping elements. And so using these two, you can quickly create different options. So this one now is still owned by Dynamo. Then whenever I swap this one, I will just bake it. And that's it. So I can even change now the type of element. And you can see that basically it's creating another one on top of the previous one. So yeah, I can keep going forever, but the main idea is that basically if you want to bake the objects and store the objects, then you need to make Revit the owner of the object. Otherwise, you can go. It's not a reversible. So you can't, once it's defined that Revit is the owner, it's just baked and it's done. You can't go and reverse it. You have to recreate it from the beginning. If you want to, you have to delete it and redo it, basically. So there's no way to reverse the task. But as much as you want to keep it dynamic, just keep Dynamo as the owner of the object. And once you are happy with the solution, then you can just make it. So I think that's what I wanted to show you for today. And the next time I'll probably focus on something a bit more interesting in terms of using, for example, adaptive components or more complex geometries. But the idea would be very, very similar, just with a bit more complicated objects. So thank you for now, and I'll see you next time.